Hello guys, welcome to my channel guys. Today I am going to explain about the topic role of Hbase in big data processing, and from your examination point of view this is also very important guys. And one more thing, I have given the entire notes drive link and in the description box. Please check it out guys. I have given all the units, unit 1 to unit 5 notes and as well as the ppts in the description box. Please check it. If it is useful, you can download it and you can use it for your examination purpose guys. So, and this is one of the important topic in the unit 4, so that's why whatever the important topics are there, I am explaining only those topic. See, what is meant by Hbase basically? Basically, Hbase is a distributed column-oriented database. It is not a row-oriented database, guys. It is a column-oriented database and which is built on the top of the Hadoop. So, if you see the Hbase or Hive or Apache Pig or Apache Avro or some other components which are there in the Hadoop system, all these are built on the top of the Hadoop only. These are not built individually. These are built on the top of the Hadoop system only. And this is also open source only guys. We are not at all using any licensed versions. Completely these are open source and free projects. And these are horizontally scalable. I will tell you why this is horizontally scalable means. And Hbase is a data model which is similar to the Google's big table. So how your Google's big table, it is nothing but where we are going to store the large amount of information. From that large amount of information also, we will be able to retrieve the random data from the structured data here. So that's why they are going to compare this Hbase with this Google big table guys. And it leverages the fault tolerance provided by the Hadoop file system. If any faults which are there by the Hadoop file system, all these we can avoid using this Hbase. So it is a part of a Hadoop ecosystem. We know that Hbase is a part of a ecosystem and where we can provide the random real-time read and write access to the data in the Hadoop file system. So one can store the data in the HDFS either directly. I can store my files directly in the HDFS, or else I can go through the Hbase also. From the Hbase also I can store my data in the form of the structured format, or else I can store my data in the HDFS format. So data consumer, see one diagram is there here. See, I am having the Hbase is there. So below I am having the HDFS. Why? Because on the top of the HDFS only I am going to use my Hbase. So I can do my reading part and I can do the writing part into the HDFS. So whatever the files are there in the HDFS, from the Hbase I can read that files. And if you want to store the files also, I can store the files in the HDFS. So we are having the data producers are there and data consumers are there. So these data producers are responsible for writing the data into the HDFS and the Hbase, and whereas the data consumer, he is responsible for reading the files from the Hbase here. This is one simple diagrammatic representation of how the files can be read and write from the Hbase and from the HDFS. Next, see how the storage mechanism is there in the Hbase guys. So the storage mechanism in the Hbase, already I told you that Hbase is completely the column oriented database here, where here also we are going to store in the form of tables only, which are sorted with the help of the row keys here. And the table schema, it is going to define the column families here. It is going to define the column families, and whatever the values are there, we are going to describe with the in the form of key value pairs. In the form of the key value pairs only I am going to describe it. And the table have the multiple column families. Each and every table will be having the multiple column families, and each column family can have a number of columns. Under the column families, again multiple columns will be there, and all the column values are stored contiguously on the disk here. And each cell value of the column has a timestamp. And in short, we can take it like a Hbase is in a table is a collection of rows, and a row is a collection of column families, and a column family is a collection of columns, and a column is a collection of key value pairs. See, if you see this diagrammatic representation, we will clearly understand that all these are the column families. Under the column families, I am having the columns are there, column 1, column 2, column 3, like that I can create many number of columns here. And for each and every columns, we are having the row ID, it is also there. So this is the row ID 1, row ID 2 and row ID 3. This is the entire picture of the Hbase, how your data can be stored here guys. And this is one example. This is my column family. What is my column family? Names here, personal data is one column family name, and Professional data is another column family names here. Then what are my columns here under the personal data? Column name is name here, and one more name is the city. And under the professional data, designation and salary, these are the columns. And these are my key value pairs. These are my key value pairs, and these are my row keys here. What are my row keys? Under the row key 1, I am having these name, city, designation, everything, all the data I am going to maintain here. This is one different way of maintaining the data using the Hbase here. So Hbase, we can simply use it, guys. And if you want to write for the heavy applications also, we can use it, we can store it. And if you want to store all the results in the HDFS, again you can store all the results back in the HDFS, and we can retrieve it again. And whenever you want for the faster retrieval and faster access, things like, we can go for the Hbase, guys. And companies such as the Facebook, Twitter, Yahoo, and the Adobe Flash Player, all these companies, they are trying to use this Hbase, guys. And this is the Hbase architecture, guys. From the examination point of view, please draw this architecture and try to explain each and everything here. And if you see here, we are having the client is there, and H master will be there, and here zookeeper will be there here. So if you see here, I am having the region servers are there here. In the H master below, I am having the region servers are there. See, if you see the client normal HDFS architecture, what will be there, guys? We are having the master node will be there, and as well as the slave nodes will be there. So this is my master node, and these are my slave nodes. And these slave nodes are nothing but the data nodes. Here also the same architecture they have replaced with the region servers, right? So these region servers, how many region servers are there? And if you want to, a client want to access any region server, means first it will ask the, with the help of the zookeeper only, it is going to assign the regions to the region servers, and all the information of the region servers will be there in the H master. How many region servers are there, which region servers are busy, which are overloaded, which are free, which are idle, all these information will be there with the H master. If and the allocation of the regions will be done to the region servers with the help of the zookeeper only. Zookeeper is responsible for all these tasks, for assigning the regions to the region servers and all. It will be responsible. Then later on, if you want to store the data in the HDFS, we can store the data in the HDFS, and if you want, you can retrieve the data back again. So this is the entire Hbase architecture, guys. See, the responsibilities of the master server are this one. This is the H master, or it is going to assign all the regions to the region servers, guys, which will take, it is going to take the help of the Apache zookeeper. And one more important point is, it is going to maintain all the load balancing also. Load balancing also will be done by the Hbase here across the region servers. If any region servers are busy, or if any are free, it will tries to manage all these free and the ideal region servers, guys. And it will maintain the state of the cluster by negotiating the load balancing here. It will tries to, in one cluster, it will try to maintain the load to all the region servers in an equal manner, and it is responsible for the schema changes and the other metadata operations, such as the creation of the tables and the column families. These are the roles and responsibilities of the master server. And if you take the regions here, regions are nothing but the tables. Whatever the tables that which we are going to use, those are nothing but the regions here, where we are going to store it in the region servers. These region servers have communicate with the client, and it will handle all the data related operations, guys. And it will handle the read write request for all the regions under it. So whatever the read write requests are there, all these things will be handled by the regions under it. And it will decide the size of the region by following the region size thresholds. So we can't take how much size as much we want. We will be having the size limitations also will be there, guys, for all the regions. And we will take a deeper look into the region server, which will contains the regions, and how we are going to store all these tables in the regions, means one diagrammatic representation they have given. So all these are regions. Regions are nothing but, I told you now, whatever the data we are going to split, all that data we are going to store in the form of the tables, guys. These are the regions, and whatever the regions data is there, that we are going to store here. We are having the mem store will be there. Mem store is nothing but a memory store, where it will act like a cache memory. It will act like a cache memory, which is a faster one and which is a smaller one. and whatever the regions data which are fetched immediately, it will retrieve it from this memory store and it will represent to the clients. And if it is overloaded, means what it will do means it will flush out all this particular data and it will free this memory store, and they will store all these files in the form of the H files. These are indexed files here, and again this memory store, it will becomes free and it will flush out all the files in the form of H files or the store files here. So entire regions inside will be maintained like this, guys. So I hope you like this video, guys, and this is about the zookeeper. Zookeeper, it will maintains all the uh, configuration related information and naming related information. All the names which are there in that regions will be maintained by the zookeeper itself, and it will provides the distribution and distributed and synchronization things. And zookeeper has the ephemeral nodes representing the different region servers and the master servers, and use these nodes to discover the available servers, guys. And availability is more here. If any track failures are there, and if any networks partitions are there, all these things will be handled by the zookeeper, and the clients communicate with the region servers via the zookeeper. Clients will communicate with the region servers via the zookeeper here, guys. Each and every time they are going to take the help of the zookeeper, and in the standalone mode, say Hbase itself, it will take the care of the zookeeper. So like this, each and every one, it is responsible for doing their own tasks, like a Hmaster or region server or the zookeeper or the client. So I hope you like this video, guys. One more time I am explaining you, like I have given my notes and ppts in the description box. Please find out, and if it is useful, you can download it and you can prepare for your examination, guys. Please like, share and subscribe my channel, guys. Thank you for watching this video.